So do you recall where we would start at the broadest, most conceptual level if we were to order these different topics? Yeah, it should have the next one. 3. And learning standard, we need 5. So where would we start? Most conceptually broadest level of the learning standards. Which one is probably the most specific? We'll get the 2 ends together, or identify the most specific. Did you say you did say objective?
Yes.
So we'll fine tune that. I think you have 2 choices for objective. You have unit and you have, I think, lesson or learning objective. So in K-12 education, when teachers do teach units, they usually are a series of lessons. Does that help you out a little bit?
So it's learning.
So it would be a learning objective. And typically learning objectives can be slightly tweaked and they're a learning outcome. Sometimes learning outcomes may be a little broader than a learning objective, but essentially as I do pre-service with faculty development workshops, the learning objective and a learning outcome really can be considered the same thing, so it makes your job a little easier. So if we start with learning standard, then we would come down, and in a school, they would refer to it as one word. They would refer to it as a curriculum. So the teacher would say, well, in our curriculum, they're talking about the school-based curriculum. So you then need to find out what content area that is, as well as in what grade level they're talking about. Of course, if you look at Indiana Learning Standards, it's structured the same way. And they'll say we're aligned with the Indiana Learning Standards. So you have curriculum. What makes up curriculum are courses, and what makes up courses are units. What makes up units are lessons, and lessons are what happens on a daily basis. So if you talk to your wife or somebody who teaches in K-12, they'll probably be talking about what I did today. They're referring to a lesson. Okay, those lessons add up to approximately, depending on the grade level, but in high school is my reference point, anywhere between probably 2 to 3 weeks adds up to be a unit. And then typically in a course, a semester course, if you add that up, I think there were roughly 5 to 6 units. And so as we think about curriculum and developing curriculum, which a number of you are doing, it's good to understand the vernacular from a K-12 perspective. Does it make sense to you? Maybe, maybe not, but that's how they look at the world. And so you have to be able to talk and speak to them in a way that they say they understand it. And that's my point of trying to make sure that you're clear about definitions. Okay? The Indiana Learning Standards is where we go to. And Amy Jones, thank you for arriving. Amy, if you want to introduce yourself, what you do in college, and then if you wouldn't mind, while I'm speaking, you could pull up the Indiana Learning Standards so that those who work here can just see where you go with that.
I'm Amy Jones, and I coordinate recruitment and outreach in our plant sciences program. So I work in 5 different departments. My position itself is actually the Office of Academic Programs, but just sort of been coordinating and working with Dr. Knobloch on this project in hopes that we can build some curriculum to take to the Hoosier Association of Science Teachers. So it's a science teacher conference. So we're hoping to have some lesson plans to be able to give those teachers and start building a relationship with them.
So thank you, Amy. And what we're thinking is rather than handing literally off a lesson plan, it would be your URL or your website to where they can find your curriculum if you are wondering what does that mean. So Amy is going to actually pull up the Indiana Learning Standards so that those of you who want to see what we're talking about, where you can go to find that. Now, as another quick review, for those of you who are here, some of you probably know this as well, work here. Indiana has their learning standards, and then there are also learning standards in other areas. What are those other areas, and why would we use those other learning standards? Someone want to help me out with that?
For example, we are using next generation science standard because it's not just, the material we are developing is not just for Indiana. We are using it for other states. So it's the more kind of a bigger standard.
Yeah, you're right on target. So if you work with an Indiana school, then you will use Indiana Learning Standards. If you work with schools outside of Indiana, then a way to catch probably anybody broadly is to use the national body of standards. The next generation of science standards is what has been referred to as for science. So science education has their standards. Math education has their national standards, and we can continue to go down the list of different subject matters that are taught in K-12 schools.
Can I just ask a quick
Please.
question? So the Indiana standards cover everything, all subjects?
Yes, they do.
And do they pull their science standards from the next generation science standards and their math standards from that? Like, how does that work?
Good
Or are
question.
they different?
Good question. There's two completely different governing bodies or organizing bodies of these standards. So just because you have a national body does not mean that that's what's going to be reflected in the state.
So our schools don't use the next generation ones then?
It depends on the school. If that's what that administration, that school says we're going to use the national standards, we'll use those. Right now, the state test is what drives which standards to use. So in Indiana, you're going to be looking at Indiana learning standards.
Okay.
So to answer your question, Indiana learning standards are essentially older or were developed before the next generation of science standards. So they were informed by the national science standards, but it was the previous version that were developed. So it's because of the way the United States has organized the educational system. And we believe that state and local government should be in charge of their the education of the children. So some countries, they believe that there should be a national curriculum. If there was a national curriculum, then this would be a lot easier to talk about. You would go to the national standards for science. All schools, state and local level, would be following those.
Is there really that much difference?
The answer is not usually if you have the state body looking at the national standards and they develop from that. But there was a major shift in the next generation science standards. So if you look at how Indiana has organized their standards and you look at NGSS, NGSS has cross-cutting themes. So they're much more global and interdisciplinary. And number two, they have also embedded this idea of the practice of science. And the practice of science is experimentation and what's the nature of science. And they may not necessarily, they may be embedded in Indiana learning standards, but they're not lifted up to the same level that next generation science standards are. If you go to the content isn't going to be that much different. The content where it speaks specifically to, look at chemical reactions related to temperature. That's going to be in bold. But they try to conceptually change the next generation science standards so that it connects to the bigger picture, what we call big ideas. These are really good questions, and hopefully it's a review for those who were here last time. It's complicated. It's not easy to navigate these standards, and especially not easy because Amy will show you there's a lot of them for just Indiana alone. And you pick a subject matter called science, and it goes through every grade level. And so what Amy did, and she can catch you up if you didn't receive this email, she'd be glad to share this with you. She pulled out the ones she thought were most relevant to college and agriculture. In the area of science, sure, and I don't know if she went into other areas. I think it was just science, so we may not catch that econ there. But since a lot of our faculty and staff in the College of Ag do science, she just focused on that. And they really appreciate that because you can do a word find for photosynthesis or chemical reactions, and you can then see what's listed there across grade levels. So that's a great starting point. Then you know where to find them in Indiana Learning Standards, you can then go to the bigger website and then see what else is around that. Okay. So whenever you're ready, you just let me know. Other questions about these learning standards? So we are tested in Indiana by the Indiana test, so therefore we use Indiana learning standards. But teachers may also, if you're working with me, also say, I also use the national standards because it's kind of their own professional call, or perhaps where the school district wants to go. But they will always be using the Indiana learning standards because of the testing. Okay. I'm standing right in the way. No light,
So really the easiest way to get to the Indiana Department of Education Academic Standards is to just Google Indiana Academic Standards. So that takes you to the DOE website. And there are multiple contexts here on the left-hand side which you can navigate through. Just to start with the workshops, and with our college in general, I decided to start with science. And so when I click on science, it goes through all of the grade levels as well as biochemistry, earth and space science for the high school levels. So what I did for the last workshop, and I'm happy to share with most of these new faces that I see, is I created a database on Excel. So I literally just copied and pasted them in, but hopefully made it in an easier way for you to navigate and utilize. So I took the K through 8 standards and I put them by subject matter instead of by grade. So life science is a pretty big college of agriculture one. So it's labeled by grade, the standard code. So that's the code that the teachers are going to be using and trying to check off their list basically. And then what that standard description is, so it can help you understand if your area would cover that standard. And it goes K through 8. These are all of the life science standards that are covered. So what I like to do is just highlight and then do Control F. And let's say, since I like plants, search for plants. And so it'll show you just basically a database where you can search what standards have to do with plants. So find next. So that can help you in organizing your lesson plans. If you like to cover something, you're an expert in a certain field, it can help you search for that. I did also go through and do high school biology 1, and then earth and space science and integrative chemistry. And those are a little harder because there's a course standard and then the codes, but they're all in here so that you can search and find. Just hoping that we can make the standards a little bit less intimidating for all of you in hopes that you'll eventually use them. Is that?
Yeah.
So I'll go ahead and send an email to all the attendees here so you can have that.
So it's a more accessible tool to kind of get yourself launched in these standards. So the other thing that I'd like to talk about is when you are thinking about creating some lesson or curriculum in K-12 engagement, do you start with the Indiana Learning Standards, or do you start with the idea of a learning objective? What do I want to specifically address? So do you start specific, or do you start really broad and general? Any thoughts?
You have to specifically.
Absolutely. So how many of you have an idea of something that you're either working on, developing, or have used? And what is that idea? It's probably pretty specific. And so naturally, that's where you start. So then you go through the process and you think about, I have this specific idea in mind. Some of you may find a resource. Some of you may find an activity that already exists and you want to adapt that. Some of you may say, no, I've really been working on this grant project, and this is the research, and so I think this is where it would best fit. And so we want to then focus on those learning objectives in that way. The key here is you start specific, and then you work backwards. So let's think through this idea of backward design. What does that mean? So I have this topic that we want to teach, and then what do I do? Nick, do you mind sharing just a specific example of what you're thinking about?
Okay. A demonstration showing that enzymes catalyze reactions.
Okay. So catalysts of enzymes, and there's this idea of demonstrating that. So that's what we want to teach. Now, what do we do with backward design? We say, well, why is this important? So that gets you to think about relevance with students. And you do that in a way of both contextually, where would they be using this in the real world? So it may be in a lab, it may be a career, it may be, it happens in the refrigerator, or in the stove, or, you start thinking about context and relevance that way. And then you also think about a concept. What's the concept behind this? What's the big idea? So you think about that at this global level, and that's what the next generation of science standards will link you up to, is what is this? So enzymes or catalysts of enzymes, it relates to what? That this idea that matter exists and matter can change. I'm speaking off my cuff, but you can help me out here, right? Because my specialty is education, not enzymes. So if I'm going down the pathway, but I've done enough of these that I try to get close, and if you want to help me find two, please do. So that's what we're doing, and we're starting, what does that sound like? Am I worrying about the chemical equations, or am I worrying about the really specific details of how the enzymes change their state? Yeah. right? So where am I starting when I think about backward design? I'm starting with an idea, it is specific, and I start thinking about context, and I start thinking about the concept, this is important, and all that is from whose perspective? From the expert's perspective or from the student's perspective? Thank you, you got it. So you see how the idea of backward design helps you to think about, from the student's point of view, what is their background, what are their experiences, what did they learn prior to this, and then I start to work backwards. What do I do next? I say, well, if I want to know if they can explain how enzymes catalyze, then I am going to need to have them do something to demonstrate that there's evidence that they understand that process. So the second step I do in that is I now think about what's the evidence. Well, that matches up really nice because we're all scientists and we like evidence, right? In some way, social science, life science, we want to know what's the evidence. It's the same thing. So then we think about, okay, what would that evidence look like? Does it align with what that learning objective is? Yes, it does. So I'm going to keep going. And I'm going to say, okay, what will I have to do in order for them to generate the evidence so that it demonstrates that they met the objective? And that's what we're going to talk about today. We're going to talk about your activity. So this idea of an activity is typically, or I can't help but look at you because I think about, you probably have lots of activities you'd love to just throw at students.
Oh, I do.
Right? And teachers love that. But what really gets you your foot into the door is when you can start with, this is the focus, this is why it's important, this is the evidence that students will be demonstrating so that we know if they get the idea why this is important or why this is a substantive content matter. And then, of course, this is the activity. So activities for activity's sake, some hands-on learning, we all love it, but it needs to be bigger than that. Otherwise, they'll say, you know, this is nice, but we don't have time for this. And then all once the door goes closed and you wonder, well, what did I say that didn't quite keep the conversation open? So it's this idea of alignment, focus and alignment. If you remember from the first workshop, focus and alignment is really important. But we like to run into the activity right away because that's the fun stuff. But notice, we go through step 1 to step 2 before we talk about what activity is. Now today we're thinking about activity. And many of you are familiar with the lecture, for sure, or this idea of let's just give them information. They should be able to memorize it and then be able to generate back to us what the correct answer is. We understand that paradigm. And this idea of learner-centered teaching, and Amy that's another website we might want to just show them. And this idea of learner-centered teaching, as you noticed already, you begin with content that's contextualized, that's important, and you start from the learner's point of view and you work backwards from there. I put together 7 modules that we're going to show URL, and if you want to go through that process, it's about 3 hours of essentially lecture that I've shared this with you. You can see the slides. And so we've used this for faculty development in K-12 teacher education for a number of years, and they seem to work. So if you want to use that as additional learning experiences, feel free to do so. But today we're going to talk about this idea of an activity. So we want to try to train you a little bit and get you into looking at some example lessons. If you're working on lessons, don't worry about if these lessons look different than yours. The format of the lessons is really just style. It doesn't matter so much. But what's in the lesson you're going to see is important. There's usually about 6 to 8 things that are in almost every lesson that would be considered incomplete. And that's where we want to keep this conversation for the K-12 teacher or with a principal so you can navigate through. I know my lesson has the 6 to 8 things that they would be looking for. So you're ready for this? If you have found this sheet and printed off a list of example lessons, and what Kaylee has done so graciously for us is she's made 1 copy of an example lesson plan. So we have the examples in front of you on this sheet of paper, and then we have 1 copy in this stack, and we'll just get that into your hands. And if you want to work with a partner, that may be a little easier to have a conversation. And we want you to then look at this lesson and see if you can understand what is it trying to accomplish. Like if you were the teacher, and you're looking for what does a lesson plan have in it? And if you turn to the fourth sheet in your packet that looks like this is a way for you to start to think like a teacher. This is what a teacher, or someone who at least has been taught how to develop lesson plans, this is the checklist that they would be using to see is it complete. So we want you to essentially become familiar with this lesson example, and then start to just informally evaluate. Does it have all the pieces, or is something missing? What this will hopefully do is then send you on to your next lesson plan activity with a more complete understanding of what a lesson plan should have. Does this make sense? All right. So you're able to look at a few lesson plans. Does anybody want to share an example of what they saw, a few observations, or what they liked, maybe some things that weren't clear? And what I'd really like to hear is not only was the content clear, but did you feel like it would engage students? Was the activity there that would engage students? So who would like to give this a try?
So the activity that I had was about food and ecosystem. I didn't like the title because it was not catchy. And I didn't know the grade level. Maybe because I work with middle school students, they use more interesting topics. And so the grade level was not clear. And then I mentioned the title. The background knowledge was really good. They mentioned about the material and they had a step-by-step program. But the activity that they considered kind of is not, I think it was not matching the objective that much. And also I like the extension part and and also the other thing that was missing was they didn't use that many examples. I was assuming that some teachers, they don't have any background on food and ecosystem, so they should provide some example, which was missing. And the other thing was missing, they didn't mention anything about the standards. So I'm assuming they mentioned maybe at the beginning of the book or something.
Yeah, we might have pulled out a section that didn't have it.
So yeah, I assume that that grade level is even mentioned there. But in general, it was good. But if it was me, I started with talking something that the student know already, then move them toward ecosystem. They talk basically about ecosystem, which is I think it's a bit hard for a student to start with. I'm talking again about middle school students. So
yeah. So this curriculum that she looked at does not have a lot of content in it. And so they tend to use videos, which we didn't give you. And the DVD has these short videos that tries to provide some type of context and a key idea that students can then have a conversation around.
Actually, I really like the idea of video, but they mentioned it as an extension. So if they don't have the projector or anything, they can make that part.
Yeah. So some of these lessons are going to be less detailed, some are going to be more detailed. So you probably saw that. Or if you glanced at your neighbors, you can see the comparison between the two. Thank you. Anybody else have a lesson example they would like to walk us through? Sure.
Off you go.
Okay, so ours was an apple a day extracting DNA from living things. An apple a day is a little catchy. Unfortunately, the lesson plan didn't have anything to do with apples, so that probably wasn't a really good title. It did identify a target audience, middle and high school science students. There wasn't a lot of context, but I think that wasn't some of the biggest issues. There really wasn't a clear connection between the lesson and the standards, which would have been helpful. There was kind of a very broad timeline, but it wasn't really very clear, and I think there were hints sprinkled out to the very detailed procedure, but if you were to use it, you'd have to sort of work out a tick-tock timeline of exactly how long each step is going to take. At the beginning, it says it'll take about an hour. but there are clearly some steps that are longer or shorter than others, and it wasn't very clear. Or as you mentioned, it'd be nice to say, okay, by this point in time spent, you should be here, and if you're not, I can gauge where you are in your budgeting time. There was a bit of an assessment, although it wasn't. Well, the part of it was well aligned with the activity, which was extracting DNA from bananas, not apples. But then there was a secondary activity where they made smoothies out of the leftover bananas, and then the questions around that really had no connection to DNA, which was the kind of point of the article. In fact, they talked about tofu and protein, and it was sort of food science, and it didn't connect very well at all with the first half of the lesson.
Well, this might be an example, thank you for sharing those ideas. This might be an example of getting fixated on activity of let's do a smoothie, or let's use apples in a lesson, and then, oh yeah, let's connect it to DNA. So perhaps there's a better way of thinking through the idea. Where do we start with in thinking through the extraction of DNA? How might students get this idea? Because it gets fairly abstract quickly, right?
Yes.
And so there's, a way to then maybe walk backwards and say, I think we can make this even more connected, more relevant. So that's what I mean by, it's easy to get caught up in an activity. Don't walk away saying Neil's anti-activity. Just remember that the activity needs to be aligned and part of the focus of what you're really trying to accomplish. When that comes together, it's beautiful. Did anybody see where they really felt like the activity and the content seemed to be very connected, or a good example of how that might work? Does anybody have a good lesson? We kind of heard a couple of different examples here.
Ours was really good.
Yeah, please.
It was getting the dirt on decomposition. And it was very clear that they had a good target audience. It was fifth and sixth grade. They had gave a nice expectation for how long it was going to take to complete the lesson. It was 5 to 6 50-minute class periods. They clearly stated the standards that they aligned with in both fifth and sixth grade. They had all of the objectives listed in words that the student would use when they were saying that what they would be able to do at the end of the curriculum or of the program. And they had individual lesson plans for each activity. They had diagrams. It was, and I told Dan, my favorite part of the whole thing is they gave the teacher the information that they needed to know as background, but then they also gave them the words that they would use in explaining something to the students, because those are two totally different ways of doing that.
Yes, excellent. And that was Celeste.
Yes.
Yeah.
The only thing we couldn't find, Dan, I didn't mark my paper. What was it? That
It was how it relates to other things that you might be covering.
Yeah. So, I mean, any kind of reference to, what happens in our school lunchroom maybe would be an opportunity for them to expand that, or another biology lesson that they're working on.
Excellent. So how many of you found that this little activity, looking at examples and talking through what the lesson should have in it, using this checklist with a peer, how many of you found this to be useful? Yes. And so this is not necessarily difficult. It's not difficult to develop a lesson. But you then find out, even among those who are trying to develop them, sometimes sell them, it's difficult to make sure that they're complete and well organized and aligned, because there's just so many things going on. So the complexity of doing this, the amount of detail, and it's multidimensional because you have a student, you have a teacher, you have the differences in students and how they learn, maybe differences in their background. So how do you do this? Well, in my best attempts, you'll see that we gave you a template of where to start with developing a lesson. So I'm not saying that this is what you should use, but this is what I try to come to in finding a middle road approach. So what we tend to see is that people like to develop content plans. and they make sure that all the content is there because that's what they feel comfortable writing. But then, oh yeah, I need an activity, and the activity becomes a caboose. And then it's not very engaging for students. So what this does is it allows you, if you get the content organized, that's good, you have that. Then this allows you to say, okay, let's make an action plan, or let's make a lesson plan that focuses on what the students need to know out of all that content. So you can see that this follows the lesson checklist that we gave you and tries to get you to think about this from the student's point of view. A 50-minute lesson, you break it apart about every 10 minutes. That's what these lines or rows are for, to help you think transitions. Because students can't sit there for the entire 15 minutes just doing one thing, unless it's, I guess, we still have to break it up if it's engaging, otherwise they'll waste their time. So I would say at this, I really appreciate your comment. At this point, everybody should have this step done. And if you're not finished up in the next minute or two, we're going to go on to the next one. Now, this next step, we would like you to focus on this. So even if it is a 50-minute engaging activity, we still want to break that up with checkpoints so that students know they're following through on that. So this is just a way to kind of get you started. I use this all the time just to start writing my notes down or pull it up on a computer and start organizing. What I like about this is that it also helps you as a teacher think about what you're going to do, what resources you need, but then in the middle column, you're writing out what you need to be telling students in their language. So assume you have content. That's what usually a lot of people have. This then helps you to focus on what the students will be doing. So from that, I'm going to kind of wrap up this notion of this is what a lesson plan could look like. This is what a lesson plan should have in it. We gave you different examples that hopefully help you to see the different styles and the trade-off of having a little or having too much. And then I wanted to transition to Amy, and she's going to talk about this idea of when she does K-12 engagement presentations, she'll go in and she'll read the audience, and she has this activity in mind. Her lesson plan's ready to go, and when she reads the audience, she has to make adjustments, either up or down, depending on what the grade levels are. And this is really tricky, so I thought we wanted to at least talk about this as well as you do this behavioral engagement.
Is that in the package, the worksheet?
Yes, I'll hand this over to you, and if you turn to, so the handouts prior to this is the backward design process. Just a reminder of when you write your lesson objectives, here's the Bloom taxonomy wheel that was mentioned earlier. And then I just walked through the checklist, and if you turn to the last, well, the second to last page, this is the worksheet that Amy has developed that she'll now walk you through.
Sure. And I also wanted to make a note, after reviewing these lesson plans, that we aren't suggesting that you recreate the wheel. So if you know that there's lesson plans and curriculum out there that you can utilize, most certainly that's an opportunity for you. I mean, even if you pull it and create a little bit of a front page for an activity or an audience that you have, just make sure you cite where you got it from. And if you have good lesson plans, you can share it with us, and we'd be happy to start creating this database of information that we can use as resources for teachers. So after we were talking about the workshop and really how we wanted to break it down, we sort of had this moment where we're like, we need to also cover what do students know at what different levels. So on this page, you can see I've sort of broken out into 5 different levels: early elementary, upper elementary, middle school, early high school, and upper high school. And really my example is I have a really simple activity. It's called Gas Gobblers. It was one of the lesson plans. It's part of the Junior Master Gardener program. But students blow bubbles, and it signifies oxygen. And then the other students who aren't blowing bubbles are animals or humans, and they pop the bubbles to show really the correlation between animals needing plants, because kids relate to animals a lot more than they do plants. So we were discussing that, and I said, well, yeah, it's really focused on first, like early elementary, but how can I utilize it in high school? And so we talk about the different vocabulary I sometimes tie in. High school, everybody likes to play with bubbles, right? So I tie that in. And so really I wanted to create this worksheet for you to understand that if you have a topic that you're really good at and you want to cover, you can cover multiple facets with that topic. So what type of vocabulary can you use? And how I would really go about this is to use that standards database. So let's say you know you want to work with 3rd graders. You go to the 3rd grade database either on the website or you pull up the Excel file that I just emailed all of you and really search what kind of words are they using, because you're able to use the word photosynthesis in early elementary school. They think it's cool when they know big words, but you just need to take a step back and make sure that they understand what you're saying. I was also discussing over here that I have done in a classroom where I've had paddles where it's like a red, yellow, or green paddle, and I'll be like, who knows this word? And so if they don't know the word, they put up a red paddle, like, stop, I don't know what you're talking about. And so that's a good way to gauge their knowledge totals. You can't really do it with a big group, and some of them might choose the paddles as weapons, so you have to be careful with that.
Use no card.
Or like even like flip it back and forth, red and green, just like a ping pong paddle works too. But really the idea that you need to stop and just make sure that what you're teaching is at the knowledge level, because that can be pretty deflating for a student if you're talking about something way over their head.
So let's just think about the gas gobbler activity. Everybody gets the idea. Blowing bubbles. Bubbles represent that the plants are going to put out oxygen. And then there's consumers of the oxygen. Some students are going to be animals, and they touch the bubble as the plants are giving it off. Let's just hear what different pairs how they would use this or adapt it into the different grade levels. Would that work?
Yeah.
And see, how would you use this? Would it be your primary activity? Would it be maybe the hook to get students interested, or would it just be totally irrelevant? So maybe we could just start with early elementary. We'll just go around the room. Early elementary, what did you guys do? Upper elementary? And then you can think about the middle school, and then early high school, this part of the room, and then maybe high school over here.
So you're saying it's the same activity, but what sort of either background information or how do you tie it into what might be their curriculum?
Yeah, so how do you make adjustments? You have this activity. Could you use it at the high school level? Or is it most appropriate that you would only use it maybe in either the younger or the upper elementary or middle school? I'm just curious. Do you see any relevance to making the adjustment in this activity? You ready? You want to take this around? I'm curious how you're going to. So take a couple minutes. I want to hear how would you make adjustments with the gas gobbler activity for.
And we feel like yes, it'd be very appropriate for the early elementary K through 3. We do think though you need to do the lesson prior to the activity, because once you get kids jumping around, popping bubbles, there's no way to get them back to square one to hear what the purpose of that was. We also think that you're going to have to take that and have a time where you switch animals and plants, because you're not going to, if somebody wanted to blow bubbles, they're going to be really upset that they didn't get a chance to blow bubbles, so you should have a time where people can switch between plants and animals.
Excellent.
I didn't mention I'm always the plant.
Nice job.
No one else gets all the time plant.
Listen to how they process this little challenge to now the next grade level. We'll keep going.
Well, we talked about in terms of modifications. First, sequencing. We definitely thought that you needed to do the content presentation before you gave them the bubble. Again, this sort of a fun thing is going to distract them, and then when you debrief after the activity, you got to collect all the bubbles. So from a logistics, we talked about that. Then we talked about also using this as an example of an analogy, and so having this as a demonstration of one example, then having them come up with their own analogies. Can they come up with another way that's similar, that describes the process this way? So a little more creative. And then there were some other ideas in terms of even maybe using some visual experiments to reinforce the idea.
Yeah.
Would expand on that.
Well, one of the things I said, and I don't know, this could be inappropriate and parents could end up complaining, but I was just like, if they could come up with something about how would we demonstrate that the oxygen is really important to actual animals, and not Rover, the dog that they actually have at home, but maybe like, ants and plants versus ants on their own, or something like this. But then maybe it's inappropriate to ask 10-year-olds to design an experiment where they're going to end up killing ants. I don't know if that's appropriate or not, I don't know. But just to get them sort of seeing the connection between, so they don't go home and just say, he blew bubbles today.
Yeah.
You know?
So with analogy, I mean, that's a word that you're going to have to do some, you use that word terms describe it. So I think with this group, you may even do a few little pre-content questions just to assess what they know. If they're familiar with the vocabulary they have to use. So.
Notice how it's building. Middle school or upper elementary?
Had a great idea.
It is almost the same because it's growing, and we added more complexity by adding having the number of plants versus animal. So we need more plants because we need more oxygen. And then the second level is the follow-up question that what happens at night. So we don't have that plant. So kind of making them more curious. And we're talking about having it indoor or outdoor. So maybe we can have some extension work to take them out so they can see the plants or maybe find some insects. Something like this that they can kind of relate to the real ecosystem.
Are you seeing the number of variables we had as we go around?
I did add the caveat, though, that instead of letting the whole class blow and pop bubbles, that I thought you could have a little more control if you asked for a volunteer to come up to do something fun, and just have one or two people in the front in a more controlled situation. Just my formative years in junior high, I would think this activity would just get pretty wild pretty quick.
So it doesn't matter so much about grade level. This idea of order or how do you manage this is coming up. Where are we at here? Are we at the from middle school to early high school?
So we're just thinking of